Welcome to this session. Let me share my screen first before we start. Let's get our presentation up and running. If you can give me a reaction, a thumbs up, I would appreciate. That would let me know that you can see my screen. Okay, perfect. So this is going to be a fun session. So here's the deal. First off, just to set the ground rules. Unfortunately, you're not going to be able to unmute yourself due to compliance and a lot of stuff. But you should be able to see a Q&A section on top of your Teams window. So that's where you can send me questions. Other than that, I guess the best thing we can do, if you end up having any troubles with the Q&A or anything like that, you can send me a tweet. Find me on Twitter, because we don't have any other communication channels just to, again, keep your identities safe. So that's what we have to deal for now. Okay, it's hard to be compliant for sure. It's kind of easy, but anyways. So we got a lot of content that I want to go through. So this session will be, and I know if you looked into the agenda, it's pretty packed. And based on that, you might assume, and that's a right assumption to do, is that we're not going to go crazy deep dive. But here's the promise. We're going to have a full picture of Azure Integration Services. So the goal for this session at the end, to leave this session with an understanding of what to use when and what's available, right? So that's the goal. With that goal, I didn't introduce myself. So I work at Microsoft. That's kind of obvious, I guess. So I lead the app innovation from a technical side for the Middle East and Africa region. I didn't put my information on the slide, right? So here's what I can do then. I kind of try to keep those slides a little bit generic, but if you want to stay connected, here's what you can do. You can find me on LinkedIn or Twitter. So obviously on LinkedIn, it's my first name and last name, and on Twitter, here's the alias you can use. Feel free to get in touch. Send me your questions or whatever. So I've been working on the Azure platform since it is actually before it was called Azure, to be honest. So that's enough of me. Let's go into the deal. So we are talking about Azure Integration Services, which means it's about either integrating the applications that we own or integrating with third parties or integrating the multiple pieces. You might call those modules or whatever you want to call. So you might have multiple pieces that consist a full solution, right? And those pieces have to talk together, right? So that might be another integration scenario. So let's go through this. And so this is the slide that I really like, to be honest. And we're going to spend a lot of our time in here because I love it. It just shows the full picture and the available resources, the available services that we have. And it's kind of, maybe you can look at this like, okay, so just to be able to do integration, do I need like 6 different services? Definitely not. This gives us the flexibility to pick really the right service as much as we need, right? We don't have to use all of this, but it's just the flexibility to be able to bring in whatever we need, right? And kind of, you can assume that there's a beautiful integration between all of these services, as obviously it's coming from Microsoft. So that's, that comes out of the box. So let's start talking about each of these. I do have separate slides, but I might not go through the slides. The slides are there because you're going to be able to get those slides at the end of the session. So you will receive a link somehow, whether the team is going to send whatever. So you will have that link. So the reason I have a bunch of slides is, again, just to be able to have something that you can refer after the session as well, right? Not necessarily to use them as part of this session, because most of the stuff I'm going to cover on this slide. So let's start with the top, right? Here's what we have: the Logic Apps. So when it comes to integration, sometimes what you need is to be able to visualize your integrations. Right? You have multiple pieces that have to work together, that have to be part of a business flow. right? A business process. So you start from one piece, then based on the output of that piece, you decide what you're going to do, and you kick off another process. You kick off another process, and you keep going. And that flow, you want it to be visualized, to be able to, see it visually and design it visually. And you don't want to go into, deep dive and maybe, hardcore write code. You want to have a visual design space as well where you can configure things, right? So then Logic App is the environment to go. And on top of it, one of the value propositions of Logic App is that it has a tons of connectors. So what does that mean? So let's say, hey, I'm going to connect with Office 365. I'm going to connect with Oracle. I'm going to connect with Dynamics CRM, whatever. So it's not limited to Microsoft services and tools, obviously. I'm going to connect to Salesforce. And then I want to kick off a process when something happens in Salesforce, like a particular event, particular record is created in Salesforce, or there's a particular, table insert on Oracle or whatever you can imagine, right? So that's where I want to kick off my process. And during the process, I might have some other integrations with some tools as well. So it's not just about, kicking off something. So maybe during the process, I just want to connect to a third-party service that is a noun SaaS product or something. Again, maybe Salesforce, right? So during the process, I'm going to go to Salesforce, check up something, query something, and come back and continue, right? So all of these integrations are actually obviously stuff that we can sit down and code, but then, if you implement an integration yourself, that means you're going to need to maintain the code of that integration, and you're going to need to build up that stuff, right? So instead, you might prefer to having hey, what if I had literally a box that I can, drag and drop onto my screen and then, be done with it? What if it was a component that I could integrate into my visual design space and kind of use that integration out of the box? And we call these connectors. There are two different layers of levels of connectors, some are, enterprise connectors, some are standard connectors. It's just a pricing thing. But at the end of the day, those connectors are one of the big values that you get out of the Logic Apps. So design space, being able to visually see and design your business flow, and the ability to use all of these connectors. If these, features make sense to you, then Logic App is the space to be. With that said, you are not stuck in a low-code, no-code platform, which is what Logic App is about, right? This is a low-code and no-code platform. And so far, I know it sounds like a no-code platform because you're able to do everything visually, but then you can actually go in and write code as well if you wanted to, or you can integrate stuff that you write yourself. So let me show you what I'm talking about. Okay, so I'm going to bring something on my screen. Give me a second. Here we go. Okay, beautiful. So this is just a sample thing that I have built for myself. I'm not going to run this. Trust me, this works. I'm just going to try to save as much time as we can for the sake of being able to cover a lot of stuff in this session. So this is a Logic App that I built just for fun. Okay, let's go. First off, here's what I should mention. This is a Logic App that is on a consumption tier. Again, I'm not going to go full-blown overboard with all the pricing and stuff, but know that there is an option that is called consumption tier, which means I'm not paying anything if this function app doesn't run. So this is essentially a serverless integration concept, which means I only pay for the amount of time that this Logic App has been executed. In terms of, you can see the durations here, right? I'm only paying for the 199 milliseconds of execution time plus the number of connector executions. Essentially, there's a separate charge for that. But the point is, if this isn't being used at all, I'm not paying anything. There is no provisioning or nothing. With that said, if you want to have full ownership, right? Hey, I already have an infrastructure. Can I deploy my Logic App into it? That's possible as well. But again, we're not going to go and discuss every different, architecture implementation. I just wanted to mention the serverless approach because it's just, something I feel like it's, not usual. So here's what I'm going to do. I'm going to click on the edit button, and this is it. This is the visual space. This is where you design your logic app. And this is how you design it. You click on this button, you add an action or a parallel branch, right? You can have multiple branches of code executions, flow executions essentially in this case. And when you click on add action, you can see a bunch of actions here that you can select. You can select the runtime, you can select the triggers, actions, and so on and so forth. You can search for whatever you want. I search for sales, and you see the Salesforce, and you're gonna see that there's like tons of thousands, maybe not thousands, I'm not sure, to be honest. It might be up to thousands. I mean, the scroll list here is pretty long, even if I search for sale, which might be argued that's a generic word, but anyway. So okay, so I'm not going to add anything. I'm just going to show you what this is about. So the first one here is actually a connector to Office 365. So again, this is a personal logic app that I have designed for myself, right? So this is connecting to my own inbox, my own Office 365 inbox. And you can see that. You can even see the code view. In this case, the code view is a JSON file. So again, I don't have to do on this side of the story, I don't have to write this JSON, but it might be helpful to know that whatever I do on the UI is actually generating the JSON code. So if you're a developer, you have the ability to go back and, put your hands into the machine and maybe fine tune something if you want to. I pretty much rarely need that, to be honest. But the moment you want to connect this to a source control engine, for example, you have that ability, right? And you can actually run this if you want to debug and stuff like that. You can run Logic App on your machine as well. So developers are able to run this on premises on their own development machines. The runtime is something that you can move to. So this is connected to my own inbox. Whenever there's an email that comes in, right, then I have a condition. So what is that condition? Let me click on it. So the condition says, hey, if the email, this is for testing purposes, right? If the email is from my personal email address, we're going to do something. So I'm checking my work email. Again, this is for demo purposes, but imagine this was the email of your manager, right? Whenever your manager sends you an email, this logic app will execute. So what's the goal? You might say, oops, I did go out of it. What's the goal? So here's what this logic app is doing. This logic app is actually running, but again, this is a test deployment, but this is actually running during the weekends. And the goal is to monitor my inbox. And if during the weekend I receive an email from my manager or maybe from a specific customer, it gets the email body, it sends it to OpenAI, right? OpenAI reads it. Obviously, again, this is a POC, so most probably we should do this by stripping PII out of that email body before sending to OpenAI. But that's fine for POC purposes. So I send it to OpenAI, and I ask OpenAI to essentially extract the actionable information and action items out of that email, and then send me an instant message on Teams. So simply, I'm building a bot that monitors my inbox, and instead of a long email that I might receive from someone, what I'm going to get is a bullet list of actionable items and important information to just quickly, skim through it as an instant message to my Teams environment instead of me monitoring my emails and reading those long emails that I might receive. So, okay, so in this case, we have a condition. We are monitoring the inbox. There is a condition. If the sender is that particular person or whatever, so here's what I'm doing. I'm converting the HTML content of that email to a text. So I'm not doing anything, to be honest. What I'm simply doing is I'm saying, hey, there are the pieces that I have. And let's go here. I'm simply bringing this into, oops, sorry about that. So by the way, this is the new designer UI. That's why I might look a little bit newbie. We can actually go back to the old UI. That's why my reactions are like, hey, I'm clicking the wrong places. And you're like, is this guy using this UI for the first time? Kinda. So this is the classic UI right now. So in here, when we click on this, you're going to see that, there's an HTML to text activity. The body comes from the email that I have received. I'm converting the HTML to text. I didn't write any code. I simply, clicked on plus and I searched for, add action, search for HTML, got the right We might need to wait for the search to happen. What? HTML to, where are you? HTML to text. It's weird. I can't find it. Okay, there we go. HTML to text. So I did bring that in, and I put my body into the parameter list. Then I am supposed to send this text to OpenAI. So I do have my own OpenAI instance. I give the URL, right? This is a pure HTTP request, right? This could be an integration with any third-party HTTP REST API. What I'm doing is I have to craft this particular JSON body. So I've simply copy-pasted the body that I want to use. In this case, there's a system message, and then there's a user message that says, read the email below, give me potential action steps and insights only. Additionally, tell me who the sender is. Cool. And then you can see this parameter. This parameter is actually the output of this previous box. So I'm simply getting the output of the HTML to text conversion, putting it into this JSON body, and sending it to OpenAI. So then I get the response back, which is a JSON response, right? So I have to start composing some stuff, right? So here I do some custom stuff. I do get the response of that body from OpenAI, and I do traverse the JSON output that I get. So I do write a little bit of code, if you count this as writing code, but I have to traverse through the JSON to get the content of the response that I get from OpenAI. So I get that. Then finally, I go to the Teams connector, which is connected to my particular account, and I send the output of this activity, the selection of the content from the JSON body, and I put that into the email body and send it to myself. And that's it. So what did we do then? So we have used two connectors, essentially. One, the Office 365 connector to connect and monitor the email. Second, we've used a Teams connector to send a message on Teams. And then we used an HTTP, it's not a connector, but HTTP activity, let's say, to connect to a totally third-party service in this case, right? A pure HTTP post REST API call, right? And in between, I have some activities that I use to, play with the data that I have at hand, transform the data, or, translate the data in this case. So, and all that, I didn't write a single line of code other than maybe if you count this little line of, traversal that I have, but I didn't write any code. I don't have to maintain the code, The only thing that I might maybe need to maintain is this HTTP call, because this is a raw HTTP call. If the API, most probably it's not going to change because there's an API version in the, URL already, but, this might need a little bit of a maintenance moving forward. But other than that, I don't have to maintain the Office 365 connection. I don't have to maintain pretty much anything else, right? And yeah, so this is one small example. This can be more complicated. This can have multiple branches of code and so on and so forth. Okay, cool. So that kind of shows us the power of this platform, right? And that's where we use Logic Apps. Oh, one other thing I want to show you actually. Let me go to the general available designer again, because I wanted to show one more thing. Okay, so what if I wanted to write some custom code? What if none of these boxes that I can bring in, built-in activities, are helpful? I just want to do something custom. So here's what I can do. I can go and say, hey, I just want to write some JavaScript code. So there's this inline code activity that I can bring in, which says, hey, you can actually write inline JavaScript. And this is it. I start writing my code. And keep in mind, on the right-hand side, I still have my parameters that I can bring in. And when I click on that, you see that, it spits out the code that helps me to access the variables and the content that comes out of this connector, right? If I had this box added at the bottom of the flow, I would have access to everything that was generated by all of the previous boxes. So it's really easy to write my custom code in here and execute it as part of my Logic app. And you might be like, hey, what if I don't want to do inline code, but I want to bring in a code that a developer could write, but I want them to exist in a separate sandbox or something. So that's where maybe you can use something like Azure Functions. And once you build your function and you deploy it again with Azure Functions, you have the ability to go serverless as well, which means if the code doesn't run, you don't pay anything. And I'm able to bring that into so for example, I have a function app deployed to my Azure subscription. It comes here, it populates it, and it even, populates the functions that I have deployed to that particular function app, and I simply click and bring that in. And all of the parameters and everything shows up in here. In this case, this is simply a say hello function, so that doesn't have a lot of complex parameters. But again, this has full integration with all of these, parameters and then stuff, the variables that I have as part of this context, right? So this is one way to bring a piece of code that developers maintain and deploy somewhere else. So maybe it's because it's too complex, maybe it's because of some other reason you don't want it to be part of your Logic app, you want to keep it outside because due to complexity, but you want to orchestrate that and make it part of your flow and be able to design your flow visually. So you can combine the two worlds, right? So that's where we go into from a no-code platform to a low-code platform. And to be honest, if you go really overboard, you can even say, then this is a full, code orchestration and function orchestration platform where you can have multiple functions built by your engineering team and then start, coming here and decide how to connect them each other, right? So that's a possibility too. So I'm not going to save this. I want to keep it clean. And I'm going to go back to our slide. Okay, cool. Second one, API management. That's a big one as well. So I want to spend a lot of time on API management because it's one of the most used services when it comes to integration. Because most of the time when we talk about integrations, we end up integrating APIs, right? REST APIs, SOAP APIs, legacy APIs, whatever. And when we're integrating those tools, we do get into a set of challenges. So one challenge might be, and by the way, when we start thinking about API management, don't think about simply, the fact that you might want to manage your own APIs, which is a true valid use case, but equally, you might want to manage third-party APIs as well. So you might want to manage other people's APIs essentially that you are using. You manage it for yourself on their behalf. I'm not suggesting that they're not managing their APIs, which who knows, but I would like to be able to have a level of control of my integrations with third parties, not only what I expose to the outside world in terms of which API management product does beautifully. So here's what API management can do for you. In terms of integrations, if you're exposing some APIs to the outside world, one of the things that you gotta make sure is that a third-party system doesn't by any chance abuse your systems. What does that mean? So let's say you opened up an API that, allows, a third party to query, orders based on an order ID, right? So what if, if that's a bad player, to be honest, they might, start using your API and start sending, hopefully your order IDs are not incremental, but even if they are not, they can start sending random order IDs. And let's say, again, this is a bad player scenario, but their goal is to be able to fetch as much data as possible in terms of the orders available in your system, right? So obviously, hey, we have the right authentication authorization, whatever, right? So this might not be an order ID, but something else. Maybe you're simply, sending a GPS coordinate and you're exposing an API that lets people query your store locations. And, they simply want to download all of your store locations, whatever. So they want to download your full data set because they think they're going to be able to use it somewhere. Again, this is a bad player scenario. The goal is, the fact is they're able to use your APIs as many times as they want. There's no limitation. You might not be even aware of the situation. They come in, they write a little script, and they start, crawling your APIs essentially. They download data. So one of the problems is, again, they get your data. The second problem is a player like that is actually using your underlying infrastructure and resources, and it might even prevent your other customers to be able to enjoy your services because this single guy is putting a lot of load onto your systems. So what is the easy way out? So the easiest way out is to have some kind of a throttling, right? You simply say, hey, for this API, I'm giving you access, but you can only send 5 requests a second, and that's it. You cannot send more. It doesn't make sense, right? So another scenario is you can expose these APIs, and you might even want to monetize. You might even want to have customer tiers, integration tiers. You might have a customer that you allow 15 requests per minute. Another might have 10 requests a minute. You can even define monthly bandwidth quotas and stuff like that, right? Have some kind of a limitation. So API management helps you do that. The other thing that it helps is API management as a product. It comes with a developer portal, which means people coming in want to use your APIs, so they want to have some kind of a documentation from you, so that they figure out what APIs you have, how to use it. Maybe they want to subscribe to your APIs, and maybe on the extreme case, you want to charge them with a payment gateway integration, right? You can do all of that because this product, can do all of your pretty much cover all of your needs in terms of exposing APIs. So the other thing that can be helpful is when you're using a third-party API, and what if they change their API schema? What if they're not doing a great job in versioning their APIs, right? They change something, and then your internal systems break. And when your internal systems break, maybe they have notified you, you didn't notice, whatever, right? Maybe they didn't even notify you. But then that, disconnect, when they break their APIs, what do you have to do? What do? You have to go back to your engineering team and say, hey, we have to revise our integration with that. How long does it take, right? I mean, they have to revise their code, and they have to do a deployment of the whatever that is, the product or the service that you have, so that you end up having a properly functional system. But if you had an API management layer in the middle and you were managing the third-party APIs, what you could have done is to do a transformation in the middle on the API management layer. So without changing a single line of code in your backend, without requiring a full deployment or whatever, you could simply go out and say, hey, I'm just going to change my transformation and I'm done. I said today. It's pretty quick. I mean, on top of that, even, being notified of all these things that breaks, I mean, you can, if once you have the API management tier between those two parties that are supposed to integrate, then you can, attach monitoring to API management and let API management tell you when an integration is broken, or you have a particular error that is being trending. If an anomaly you have in terms of an error for a particular API, internal or external, doesn't matter, by the way, you can monitor all of that. And you connect it with application insights, and application insights sends you an alert before your customers start complaining that, hey, this functionality is not working, and you figure out, oh, well, that's because our integration with the third party has been broken because the third party has done something or whatever. So the other improvement that you can do is increase the availability of the third party on their behalf. How do you do that? You implement caching, right? You don't implement just caching for yourself. You can implement caching for a third party. What if the third party is not available? If you had cached their data on their behalf, again, you have to decide your own caching policies. It might even improve the availability of your third-party system, which means probably it's going to improve your availability for your own customers as well. So these are some of the common scenarios that we can think of. And for that, let me show you something. Okay, in terms of looking into how this really works, right? So I am gonna bring this one. So I have an API management deployed here. Again, here's the funny thing. I mean, in this case, I have a developer tier, which means, this is a developer account. You have the full-blown functionality of everything, but there is actually a consumption tier for API management as well. So, so if you look at API management, if you look at the premium, for example, it comes with beautiful functionality and all that. So, but what if you don't need, the developer portal, right? Hey, I just need, a little bit of caching and throttling. I just want throttling, maybe. That's it. I just want to make sure people can't abuse. In that case, you can fall back to the consumption tier, and you only pay again for the use. You don't have any provisioning or anything. So that's available. So, okay, what am I going to do? Hopefully I'm not going too fast. Let's take a breathe. I'm just trying to rush in a lot of content. And that's not a bad thing. I mean, we're trying to be efficient with our time. So I see someone raising a hand. So I am gonna see if there's a question in the Q&A section. 2 hands. Okay. So here's what I can do. I can wow, 3 hands. Okay. Oh, all of them gone? Back to the thing. API management. So here we are. So I'm going to go into APIs. I just want to show you a couple of scenarios. First off, obviously, when we create an API management service, the first thing that we do is we start onboarding APIs, and that's kind of pretty easy. You can come in and say, hey, I have raw HTTP stuff that I'm going to come in and define myself. Or, hey, I have a Swagger file, open API, file endpoint that I want to bring in. I have VSTL because I have some SOAP services. So you can automate the import process of those APIs. If your APIs are already hosted in Azure, here you can see a couple of stuff that you can directly integrate as well. So the first thing I want to show you is this one. So let's go. So this is an API that I have already imported. This is the Say Hello API. This is hosted as an Azure function, which means, and this is on the consumption plan, which means, I'm going to pay as much as it's used, but then, if, someone decides to abuse my API, my end of month invoice will scale as well. So it's beautiful that the platform can scale and fulfill if there's a bunch of people coming in and using my APIs, but then if that's an abuse, then it's not a nice thing, right? So I just want to prevent it. By the way, just so you know, you can go into a function app and put a monthly limit, but I don't want to do that. I want to give, separate subscription keys to every customer, that I have, and I want to have separate limits for all of them. So in this case, what I'm doing is I have imported my API already. On top of that, what I do is I go into this inbound processing. So here we actually have a pipeline, which means there's an incoming request, right? It goes through an inbound processing step. Then it lands into a backend. The backend in this case is a function app that I have deployed, right? And then once we receive a response from the backend, we have an outbound processing. And then we send the response back to the third party or whatever that is, right? So we are able to do processing on the incoming request before it lands to the endpoint where it is supposed to land, maybe the backend or whatever that is, right? And then we are able to reprocess before we pass on the output that we receive to whoever that we're gonna, serve the content to. Okay, so this is a total, essentially some kind of a middleware or proxy or whatever you want to call it. So what I have here though is rate limiting. So when I click on this add policy button, you're going to see a bunch of policies that you can add here. One of them is limiting the call rate. And I actually already have that integrated. So I'm going to click on this little icon here. That's going to show me the policy stuff implemented. So disregard this part. So I'm going to cut it. Okay, that's a different topic. So this is what we have to do. In this case, what I'm saying is, hey, I'm going to rate limit by key. I can customize that key, by the way. You can define a custom key. But in this case, I decided to use the subscription key that the API management gives to my API subscribers, people who are going to access my API with a particular, access key, right? So I'm going to use that key as the counter to count the number of times this API has been consumed. And then I'm saying like, hey, every 60 seconds, you can only call this API twice, and that's it. You cannot call more than that. If you decide to call more, I'm not going to pass your request to the backend, right? The backend system will not get that. So that's as simple as that. I don't have to do anything. This is it. And this might be the whole way you use API management, maybe, and you go with the consumption theory and you're fine. So the other code that I had in here, again, just for the sake of the time, I'm just going to explain this, is, hey, I want to do JWT token validation before you hit my endpoints. I don't want to do it on the back end. I want to delegate that into the middleware on the API management layer. So what you see here, and there are different options. You can give an open API, endpoint. that you can use for the public key can be fetched from there. You can use a certificate or whatever. But for the sake of having a simple demo, what I have done here is I have a public key that I have directly copy pasted into the policy itself. So what I'm doing is, hey, there's going to be an authorization header, right? If it's not valid, throw 401. Here's the error you're going to throw. It's going to be a bearer token. This is the public key that you're going to use to check if the JVT token is signed properly. Here's the audience. Here's the issuer. Here are the claims I require. So if this validation, first off, the important thing here is that this validation happens before the request goes to your backend. If this is not validated, your backend will not be hit at all. If this is validated, then your backend receives. And you can do stuff like, maybe out of this authorization, you can decide what to pick. So maybe you want to send the claims to the backend as well. You can still do that. So the claims have been validated, but then you still want to send the claims to your backend because the backend is going to do something different with the claims. Maybe it's going to allow some operations or whatever, right? You can do that here as well. Totally up to you. So there's a lot of flexibility. So how do you do that? How do you actually transform the request, incoming or outgoing? So that's what I'm going to show next. And for that, I have an interesting example. Again, this is about, nowadays everything is about OpenAI. So this is another example with the OpenAI. So what I wanted to do is to simplify the OpenAI API. So what I want to do is just to send a single, request and get a response, and that's it. And I don't want to have the complexity of the OpenAI's API schema or whatever. I just want to have it really that complex. I want to have an API where you send a JSON object with a question and I return you the answer. That's it. No discussion, no chat, no structure, no prompt, nothing. Okay. So here's what I did. In the backend, I have defined a custom HTTP endpoint and I put in the information, the endpoint information for the OpenAI stuff. Okay. In the front end, my API is simply says /ask. That's the endpoint that I have. So I am doing endpoint transformation as well. So from to the outside world, I'm exposing a different endpoint. On the back end, it's totally different. So for the inbound processing, I got a couple of stuff. So let me click on this one and let's look into the code. Can I hide some of this to get us a little bit more space? Yeah, okay, this is better. Cool. So here's the deal. Inbound processing. This full file, by the way, this XML file has both inbound and outbound policies, and this is something that if you want, you can put into a Git repo or whatever, so you can source control this if you want. So inbound processing, the request comes in. The first thing I do is I add a header, because the OpenAI APIs requires an application JSON header, but I don't want to require it from my users because I'm too good. So I just want to accept anything, right? I need a valid JSON, but I don't require the header, whatever. So I'm adding the header before I send the request to the backend. In this case, OpenAI, which is not my backend, by the way. Keep in mind that's literally a third-party service in the context of if I have building an app, that wouldn't be part of my app, right? So then I'm rewriting the URL from /asks. I'm going completions, okay? Because that's what the backend API requires. And then I'm using a transformation, a liquid templating here. There are a couple of different templating engines, but this is the one that I really love because this is crazy easy. I simply copy paste the JSON that the backend requires, and then I put the information I got from the incoming body. So the incoming body is JSON, and this is how you can traverse in the JSON schema. So I'm simply saying, hey, there's going to be a body and there's going to be a JSON attribute in it called question. Get the content of it, put it here, put it in this JSON schema, and send this to the backend. That's all. This is how you can transform things. Crazy easy. If they change their schema, what I'm going to do is just come here, paste the new whatever has changed, and then move the right thing into the right place, and I'm done. I'm just going to click save and I'm done. Okay. So I have something else, and which is I have to add the version number of the API into the query string. So I go and use another policy which says set query parameter, name API version, override it. If there's an incoming, API version query parameter, I'm going to override that and replace it with this one. So again, what did we do? We changed the body, we added a header, we added a query string value during this transformation for the inbound process. And when it comes to the outbound, I get a JSON body back from OpenAI. I don't want to send the whole thing. I just want to send the answer. And in this case, again, this is the response body I get from the backend. I go through that, get the first answer essentially, and send it back in this JSON schema. So let me show you how this works. This is pretty easy. So, oops, no header is required. So I'm going to do this. Question. How are you doing? Okay. So I'm going to send this. So this is the endpoint that I'm sending, by the way. This is not the OpenAI endpoint. I'm sending this to the API management instance that I have. And obviously you can customize this domain name and stuff. So I'm going to, oops. Yeah, I have to delete this. Okay. Send. So the transformation happened, request sent, and here's the response that we have. As you can see, the JSON body, the JSON schema is my own schema. So I'm simply sending back a content, which is the answer of the GPT, in this case 3.5. I'm an AI language model, so I don't have any feelings. Okay, fine, whatever. So this simplifies your implementation. If this is the scope that you need, right? You don't have to implement that complex schema or whatever of OpenAI into your client apps or whatever. You can maybe even combine this, and you can actually do 2 backend requests and have the results and combine it into a single response. Maybe this is going to be part of a body that you want to send that combines an answer plus some data from your database and all that. You can definitely go crazy with this. It's pretty flexible. Okay, but at least we have seen how to manipulate the incoming request and the outgoing request by totally transforming the whole, essentially we're transforming the whole experience that an external developer would have with our APIs compared to what was available in the backend. So totally decoupling the two systems from each other. Okay, perfect. So what else do we have? Okay, let's give a break. Okay, the 2 big guys, we covered those. Those are the 2 big guys. The others, I'm not going to do hands-on demos with the others. So Event Grid and Service Bus. So let me talk about Service Bus because this kind of is easy. As the name suggests, it's enterprise messaging. If you need messaging, you can use it between your microservices maybe to how microservices communicate with each other. It's not a simple queuing mechanism. It has PubSub. It has a bunch of different functionality that is pretty much whatever you can expect from an enterprise messaging platform, right? There's no other, messaging. I mean, you might argue that there are some others, but again, in terms of purely focused on messaging and having the richest capabilities and everything, this is the service in Azure. So if you are building a system that requires messaging, I'm not talking about eventing. So what is the difference between eventing and messaging? One is to send information. The other one is to notify, right? Send an event. Literally, the payloads are different. So with a message, you can have a larger payload. With an event, you are supposed to have a minimal amount of payload because you're simply notifying the system about something. If there's a need to pass on data or whatever, most probably it's saved somewhere else. So the target destination will have access to it as well, and they will have their own access implementation. But when it comes to messaging, the message might have a payload that could be useful by the destination. So that's Service Bus. That usually shows up when you have lower level integrations in terms of most probably you have access to the source code of whatever you are integrating with or between, right? So then there's Event Grid. The story is pretty much the same in terms of you most probably have access to the source code of whatever you're integrating with. But here's what's interesting with Event Grid. It is the only service. That's what's interesting with Event Grid. It goes out. What does that mean? So when we think about a PubSub mechanism or whatever, a queuing mechanism, usually what happens is, You send a message into the queue, whatever, right? And then someone comes in and reads, or someone stays connected and does polling, right? In the case of Event Grid, someone comes in, subscribes. But by the way, you can do it the other way around as well. You can definitely go on and do polling with Event Grid. And this is actually a new feature of Event Grid. It wasn't there before. It's announced at Build recently. But the core, how Event Grid came up was the fact that someone comes in, tells you, hey, this is my endpoint. Let me know when something happens. And that's it. As a third-party system or as the listener, right? You don't have to actively listen. You don't have to connect. You don't have to check on something. You just come in only once and say, hey, this is where I am. This is my endpoint. These are the types of events I want to listen. If something happens, let me know. And you are done. Event Grid will reach out to you. When an event happens, it's going to reach out to that listener itself. It will deliver the message without expecting a polling or a connection again. And if the delivery fails, Event Grid itself will try. So there is a retry policy that you can customize as well. You can find it in documentation. I don't know off the top of my head, but there is a retry policy, and there is a built-in that lettering as well, which means, if I'm not able to deliver for about 24 hours, then I can put the message somewhere else in a storage so that you can process or whatever you're going to do. But the goal is, you do have this system where you can put an event, and you can rely on that managed system, managed service, in this case Event Grid, to deliver your message on your behalf with a particular retry logic without expecting the third party to come in and check on things. So that brings a pretty interesting level of efficiency. Especially you have, millions of events and, a bunch of listeners and so on and so forth. So for example, that's how. So Event Grid is a foundational service when it comes to Azure, because Azure itself is using Event Grid. For example, if you go to Azure Storage and say like, hey, I want to monitor if there's a new file uploaded, you have two approaches. First, you can go ahead and, every 5 minutes check out if there's a new file uploaded. The other option is you subscribe to the Event Grid topic of that storage account. So Azure services themselves are actually Event Grid publishers. So you can have your own publisher as well, right? But Azure services are publishers as well, so that you can subscribe to an Azure service and say, hey, if something happens, here's the event I want to be notified. Here's my endpoint. Let me know. I don't have to actively listen. So it's a beautiful, capability, a service that is able to go out and deliver on your behalf. If you needed this functionality and Event Grid wasn't there, imagine you would need to, essentially write this whole thing ourselves. So that's what Event Grid is. So then we have two other pieces, right? Functions and ETL. I'm not going to go into the ETL territory because that's actually a totally different topic. It's part of the integration services, but it's data factory, CNAPS, whatever you can do. It's bulk data transfer, bulk data, transformation. That goes into a, separate territory. But, it's available there. If that's what you need, that's something that you can dive into. I'm not going to go into it in this session. And the final piece is functions. So functions is a highly critical piece, even though you might not think of functions as a standalone integration tool. It is a critical piece in terms of filling in the gaps, or sometimes I call it being the glue in all of these integrations. Whenever you need an extensibility point, like the example that I showed about Logic Apps, being able to build something highly customized and being able to integrate that into your Logic app. So for example, maybe you want to listen to an Event Grid and you don't want to build a full-blown app. Maybe you can have an HTTP function deployed. And the beauty of that, having the consumption tier, which means, again, if it's not used, I don't pay anything. It just makes it easy. Because every time you need to build a little piece of code that is going to connect to dots, maybe due to legacy systems or whatever, right? Every time you have that need, the question is, what are you going to do? Are you going to build a full, app from scratch, and where are you going to deploy it, right? Just because you want it to run, 10 lines of code, should we spin up a new project and, figure out, an infrastructure for it and so on and so forth? And if you have a lot of those, so those are small pieces of code that are supposed to do something, right? But then, it's too small to, deploy to a full-blown infrastructure. But then we still want to have the capability of being able to scale it based on the amount of integration load that we get. So all of these requirements, they are perfectly fulfilled by Azure Functions. So you end up seeing Azure Functions as the thing that is being used. I sometimes, use the example of a, SQL store procedure, or sometimes SQL triggers, because functions have their bindings and triggers as well. You can definitely connect. Let's go with an example. What if, we have mentioned that when you upload a file into the storage, you can actually kick off an event grid. But what if when a file has been uploaded, you want to send an email? So you have a couple of options, by the way. Maybe the easiest one would be Logic App. You can connect it to the event grid subscription, right, of the storage, and then connect it to an Office 365 inbox, and then send an email from there. No code. But what if you have something a little bit more complex? So maybe you can use an Azure function to listen for an event grid, to wait essentially for an event to happen. And once the event happens, that function code executes and do whatever you have to do, right? Another option is maybe if you're going to simply call a third-party API, right? And if they're not compatible, because when it comes to event grid subscribers, during the subscription, there's a particular schema that you have to follow. It's not a proprietary schema for Microsoft, but still there is a schema. I don't remember the name of it, to be honest, but there is a particular schema that you have to follow. So what if this is a legacy system that is not able to follow that? So you have to have something in the middle, right? So you can do it with a function. You can have a function that is deployed, that doesn't execute. You don't pay anything, but then when an event happens, the event is sent to the function, and the function does the transformation and sends it to the third party. Another option is maybe you can even have API management for that, right? You have the event sent to an API endpoint in API management, and you do the inbound processing to send the API to the third party. So these are all, different options based on, your needs and how you want to build and maintain those systems, right? You can pick and match different tools and combine these. Okay, perfect. As you see, I have spent all my time on this slide. I didn't use any other slide. So let me see. I'm simply gonna jump to the final slide here and say thanks. With that, let's go, and I'm gonna share my contact information with you again. So this is who I am, and this is Twitter. This is how you get to me on LinkedIn. If you have any questions, I know we're out of time. Feel free to reach out to me. Message me on LinkedIn, message me on Twitter, whatever works best for you. Let us know how you feel about this session as well. Give me your feedback, because we will keep doing those. If you feel like it makes sense to dive deeper into a particular topic or a totally different topic, any type of feedback is more than welcome. Thank you for all being here, and see you on the next one.